problem, we're going to compute f prime of 4 and find an equation for the tangent line. Okay, so first of all, we have to compute the derivative at our x value of 4. So a is going to be equal to 4, all right? And so let's pick a definition of the derivative. And in this one, I'll pick the less commonly used one of x minus a, or x approaches a, sorry. And then we have our f of x minus f of a over x minus a, all right? And in this case, I'm going to kind of hold off on plugging in this a equals 4 until the end, until we get a formula for f prime of a. Okay, so first of all, we're going to plug in the function for each of these. So this is going to be limit as x goes to a of f of x is 1 over radical x, and this is going to be minus 1 over radical a, right, if we plug in an a for our x spot, and then we have an x minus a on the bottom there. Okay, so on the top here, let's get a common denominator and see what happens. So this is going to be equal to limit as x approaches a, and then we have a square root of a on the top over square root of x times a minus square root of x on the top over square root of x times a again. Okay, so we have that, and then on the bottom we can't forget about our x minus a there. Alright, so how are we going to write this? Let's see. So if we want to flip the bottom to the top, so we're going to combine, well, okay, so first of all we're going to combine the top there, the numerator, so that'll be an square root of a minus square root of x over square root of x times a, all over x minus a, and on the bottom that's a 1. So we got a lot of fractions going on here, but all we have to do is keep them straight. So we have this top fraction here and the bottom fraction, and now I'm just going to flip that up and multiply times the reciprocal. So this is going to turn into limit as x approaches a of square root of a minus an x, square root of x, over square root of x times a, and then we have that times 1 over x minus a. Okay? So now that we have this, we can write it more simply as limit as x approaches a of a square root of a minus square root of x over x minus a times square root x times a. Alright, so now that we're at this point, and forget that one right there. Yeah, so we're at this point, and now we'll continue on the next slide. Okay, so now what I want to do is kind of rewrite it a little bit. And on top, you know how we had the negative, or of the square root of a minus square root of x? I just want to flip that around, okay? And I'm going to write square root of x minus square root of a. So by writing it like that, I'm taking out a negative sign, okay? So there's a negative out here, and then on the bottom we have this x minus a, and then square root of x times a. Okay, so my reason being is that I wanted the x first, the square root of x first, and the square root of a second, because I want to kind of mirror what's down here, right there, okay? And you'll see why. So now what I'm going to do is multiply by the conjugate, and we're going to rationalize the numerator, okay? So again, multiplying by the conjugate means you multiply both top and bottom by something, and then that something is composed of the terms that we see up here, okay? So a square root of x and a square root of a, but you change the sign in the middle. So we're going to change that minus sign to a plus sign. Okay, so these are both conjugates of this original grouping. Okay, so let's see what happens when we do that. So we're going to obtain limit as x goes to a of, and we have this negative sign out in front. Okay, so that negative sign's still there, negative 1, and then we get an x. So this actually turns out to be, sorry, that's not an x, that was an a. Okay, so we get an x, and then this will be minus an a. Okay, because that turned out to be the a difference of two squares, right? So if you were to FOIL that out, you would get square root of x squared minus x times a plus x times a plus square root of a squared. Sorry, minus a square root of a squared. Minus, there we go, a square root of a squared. And these two terms cancel out in the middle, and those turn into an x minus an a. Okay, so that's how we got that. And then on the bottom we have our x minus a there. So this is looking nice, right? So we have something that looks like that. Okay, so at this point what we can do, oh sorry, and can't forget about this, is we have our square root of x plus square root of a on the bottom. So I did the top, but I didn't completely, yeah. So anyways, that's still there, right? So we have everything's kind of squished on the bottom there. And what we can do with this limit, I'll draw a line here so you don't get confused between those two, is cancel out the x minus a on the top and the bottom. So what we're left with is a limit as x approaches a of -1 over square root of x times a, okay, that's in there, and then this is being multiplied times square root of x plus square root of a. Okay, so from here, I believe this function that we see here, our f of x, is continuous at a right now, so we can basically just do direct substitution. So we'll put in the a wherever we see an x. So we're going to put in an a here because we see an x there, and we'll also put in an a here because we see an x there as well. And then these a's were there already, the ones that aren't in parentheses. Okay? So now let's just simplify it and see what we get. So this is -1 over, and then we have square root of a squared. So that's just going to be an a here, okay? And then we have a 2 times the square root of a. That's what we get. So what this is basically a 1 over 2 times a to the 1 1/2 power, so the 3/2 power, okay? So that's going to be, another way to write that is just -1/2 times a to the -3/2. And this, so this final thing here, that's our formula for f prime of a. Okay, so now what we can do is take that formula, so we're going to take our f prime of a is equal to -1/2 times a to the -3/2. We're going to take that, and we're going to plug in our a equals 4. Okay, so f prime of 4 is now going to be -1/2 times 4 to the -3/2. So another way we can write that is a -1 over 2 times 4 to the 3/2. Okay, and let's solve what this is. That's -1 over 2 times the square root of 4 is a 2, so 2 to the 3rd, and that's going to be -1 over 16. Okay, so this is our f prime of 4. So we found that. That was the first part of our question, and don't worry, the first part was the longest for sure. So this is our f prime of 4, which also happens to be the slope of the tangent line. So that's good. Slope of tangent line here. So we have that, and now all we need to complete the equation of the tangent line is the point that it goes through, is a point that it goes through. Okay? Alright, so let's keep that slope in mind. So we have our f prime of 4. That's equal to -1 over 16. Now we know that our a is equal to 4. Now we need to know what is f of a. What is our y value, or our function value at a, okay? And that'll be our last component that we'll need to know to write the equation of the tangent line. Okay, so what is f of 4? So what was f, first of all? So f of x, if we've forgotten, is equal to 1 over square root of x, okay? That's what we started with. So if we plug in our 4, f of 4 is equal to 1 over the square root of 4. So that's just going to be a 1/2, right? A positive 1/2. So this is our f of 4. Our x value was 4, and we have our slope as well. So we're going to plug this in for y, this in for x, and this in for the slope. Okay, so we can put it all together. So our equation of the tangent line, is going to look like the following. We're going to have y minus our y value. So that's our f of 4, also known as 1/2. And then we have equals the slope, so that'll be our -1 over 16, times x minus our x value, which was 4. So x minus 4 there. Okay, and then we can simplify a little bit more. So this will turn into y equals -1 over 16x, and then this is plus a 1/2, plus a 1/4, and then plus another 1/2 from over here, from this side. I move that over. And then this will turn into -1 over 16x plus a 3 over 4. So either this one here in point slope form, that works just as well, and here I just simplified that even more so. And this is also another equation, another valid equation of the tangent line. Okay, so that's it. And again, our f prime of 4 was -1 over 16, which we did utilize in the equation of the tangent line. Okay, so that's it for the practice problems video. I hope that helps, and happy studying!